Okay, so in this class we'll do this numerical test portion. 9B, let's go to 9.5 example. First, open your textbook to page 129. Okay, let me read the question for us. So there is a velocity time graph given. So let us draw that first. Here. Origin is not given on the question, okay, but it should be 0. You corrected yourself. And here is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Up to 10 seconds. So this is the time axis in seconds, running from 0 second to 10 seconds. And here 5, 10, 15, I think up to 25 is given, and this is given in the velocity in centimeter per second in this axis. And a graph runs from 20 and the object stops moving after 10 seconds as a straight line. So here, from this velocity versus time graph, we can take out some information here. So clearly, if you look at the ball, the velocity time graph of ball mass 20 grams, so m equal to 20 gram, which has to be changed to kilogram by dividing by 1000. 0, 0 cancel, because the SI unit of mass is kg, you know that, right? So 1 kg is equal to 1000 gram. SI unit follows the MKS system. So for calculating distance, it is meter, mass is kg, and time is seconds. So the mass has to be changed to kg. So divide by 1000. So 1, 2 zeros. So here decimal will shift 2 places to the left. So 1 and 2 places here to the left of this 0, and kg is the mass of the ball that is moving on the table. Okay, so as you first saw in the table, you saw here U means at 0 second is when the ball appear first. So that is having 20 centimeter per second as the velocity. Now we need to change this centimeter to meter, because the SI unit of distance is not centimeter, meter. So kilometer, hectometer, kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter. We have to be very well versed with this by now, because we will need this frequently, right? So I want to change centimeter to meter, so changing small to big and 2 places, 1 and 2. So this 20 has to be divided by 1, 2. So 2 zeros, 1 place move is 10 and 10, so 100. And then centimeter will become meter. Then second down here, that is fine. SI unit of time is second only. We can keep it like that. Then you can cancel this one if you want. And so because of this 0, decimal will move to the left of 2 and become 0.2 meter. And if you shift this to the numerator with meter, then second to the power plus 1 will become minus 1. So this is the initial velocity of the ball when you first saw it rolling at 0 seconds. Then, as we see here, finally, how much force does the table exert? So that is the paragraph after the graph. Force, we don't know. Force exerted by the table on the ball, most probably friction, therefore, to stop the ball, that we have to calculate to bring it to rest. So since question clearly said it is brought to rest, that means the moving ball is brought to rest by the friction force of the table. So rest means the key word here, finally it will come to stop here. So final velocity will be 0 meter per second, right? So that is your final velocity, if you like to mention. Now one more thing, since the graph is okay, before that it came to stoppage here, 0 meter per second after 10 seconds. So the time taken for the ball to stop rolling is after 10 seconds. So that is the time. Finally, since the graph is a straight line, so straight line means the ball is in uniform acceleration, say, let us say A. Okay, this is important because if only when it's in uniform acceleration we can apply the formula of motion, right? So that is there. Then you write here, since we know force exerted by the table will be mass of the rolling ball into acceleration of the ball, so we can change this to m into v minus u divided by t. As you know from our previous chapter, motion also, we know there's a famous equation called v equal to u plus at. So if this at is kept on one side, then this v and u go this side, minus u. And so if a is kept this side and you shift t, then into t will go down here. So a is v minus u by t. So here m is 0.02 kg, as you can see here, into this portion. I think we can rub it out now. Here v is 0, as we just saw now, minus u is I think we wrapped it out, but u is 20 by 100, so 0.2, and then meter per second can come out common here. Time is 10 seconds, as you can see here. So if you calculate this, you're going to get 0.02 kg. 0 minus 0.2 is minus 0.2, just as 0 minus 3 is minus 3. So 0 minus 0.2 is minus 0.2 by 10. And here meter per second. Then if you shift this second to the power plus 1 to the numerator along with this second to the power minus 1. So next step, that will give you 0.02 kg into minus 1 0 means the symbol will still move one left to the left of this 0. So it will become 0 minus 0.02. Okay, and then minus 0.02, then this one, meter second to the power minus 1 is minus 2. So meter per second square you'll get. So now we were going to get here, multiply these two, plus first sign, plus and the minus is minus. Then I hope you're getting right. These two multiplied will give you 2 2s are 4, and decimal place you count 1 2 3 4. On the right side of this point is called decimal place, 1 2 3 4. So 1 2 3 and 4. So the decimal will come minus 0.0004 kg meter per second square. Now this is kg meter per second square is the best unit of force, and we know in honor of the scientist Newton, we can write this one simply as Newton. So we found out the force exerted by the table is negative. So we write that. Okay. So what does that tell you? Therefore, you can write here, force exerted by the table, that means on the ball, that is force exerted by the table on the ball, the friction force is 0.0004 Newton, comma. Now to here your sign has to be correct, minus. But here if you write minus also okay, you don't write also okay, because you're going to mention here. And minus means what? Negative means the friction force of the table is in the direction opposite to the ball, that means the rolling ball. Okay, so that is your answer. Negative force means the force is acting opposite to the direction of the moving object. Okay, so next, these two 9.5 and 6 we'll do in this class. In the next class, this 9.7 and 9.8. So let us go to 9.6. Example 9.6. Okay. We read the question for us. Page number 132. Okay, I read. A bullet of mass 20 gram is horizontally fired with a velocity of 150 meters per second from a pistol of mass 2 kg. So here, as we read the question very clearly, let us denote MA equal to mass of the bullet, 20 gram, which has to be changed to SI unit by dividing by 1000 to kg. So these two zero cancel, so 1 to 0.02 kg, and MB is equal to 2 kg, I think, if I'm not wrong. Yes, are the masses of the bullet, first one, and pistol respectively. So mass of the bullet 0.02 kg, mass of the pistol 2 kg. Then let us write here, by common sense also we know UA. By now we know that we have to use the formula for momentum. Total momentum before collision or before interaction. MAUA, so initial, that's why before initial. That's why you're using U, second object, mass of the second object into initial velocity of the second object is always equal to total momentum, mass of the first object into final velocity of the second object plus mass of the second object into final velocity of the second object. This formula is going to be very important besides F equal to M into A. So here, total momentum before collision or before firing pistol is equal to total momentum after interaction. So UA, UB, in this case, by common sense also we can understand this one, will be 0 meter per second RD initial, or we can simply say are the velocities of the bullet and pistol before firing. Before firing, the bullet also, the pistol also is stationary, that's why it's 0. Then the question is saying VA equal to 150 meter per second is the velocity of bullet after firing. Look there into question. Yes. So you can assume here, add a sentence, let bullet be moving from left to right. You don't need to do this, but if you do this, I find left to right say. So we're assuming. I find that it is easier. So let's just do that. So that's for, we'll just put your plus then if you want. If you don't put also okay. Left to right is always plus, okay? So velocity of the bullet after fire. And then let us say VB is equal to question mark is the recoil velocity of the pistol, which we have to find out. So after firing, the velocity of the pistol that shoots backward towards the shooter is the recoil velocity. That one we don't know. So we're going to use this formula. Total momentum after firing the pistol, let us say. So total momentum after fire is this one, MA VA plus MB VB, this portion of the formula. So let us write that one down. Mass of the MA is pistol, so 0.02 kg into 150 meter per second, as you can see here. VA plus here MB 2 kg pistol into VB, recoil velocity, we don't know. So if you use this 0, the decimal will move here and become 0.2, because the 0 moves the decimal to the right. So multiplied to 15 will give you 15 2s are 30, 1 decimal place. So this 2 multiplied will give you 3.0, means 3 kg meter per second plus 2 kg into VB. Let us put this one as equation 1. This one 2 kg into VB. This 2 is 3. You multiply this, you'll get 3. Right. So once we're through with that, we have to find the total momentum. Likewise, before firing. The formula will be the left portion here. Before is UA, this portion UB. So it will be equal to MAUA plus MB UB. So here they'll give you MA is 0.02 kg into this one 0 meter per second. MA you see here 0.02 kg into UA is 0 plus this portion also MB is 2 kg into 0 meter per second, because UB is MB is 2 kg, UB is also 0 meter per second. So here 0 plus 0, so 0 kg meter per second. 0 multiplied to 0, 0, 0 multiplied to 0, so 0 plus 0, 0. Equation number 2. So we're coming towards the end of the answer, recoil velocity. So let us do that. Therefore, according to the law, according to the law of conservation of momentum, we did this in our previous class. Total momentum before collision or after collision, whatever. Total momentum after or before, whatever you like to write first, is up to you. Equal to total momentum before fire. So it's up to you. If you write before fire on the right side, then after fire on the left. If after fire on the side, before fire on the left, up to you. Now here total momentum before fire, after fire is here, this one. Here, before fire is this one, after fire is this one. So you write 3 kg meter per second plus 2 kg into VB, that is the total momentum after fire. And before fire, this portion is this 0 meter per second. And we can write here, since using equations number 1 and 2. Just do slowly and thinking, it's not hard, okay, but you can make mistakes if you don't concentrate. So here, the term containing VB, recoil velocity, is VB, that we want to find out. Keep it on the left side, don't move. Then here 0 can disappear, so 0. So this one can be left out, and this plus, you shift it this side, then become minus 3 kg meter per second plus 0 into meter into 0. So you may as well not write it. So final VB will be minus 3 kg meter per second divided by 2 in 2 kg will go the right side, means into means it will come down, and so this kg will cancel. So minus 3 by 2 meter per second, which is minus 1.5 meter per second. When you divide 3 by 2 you get 1.5. So we can write there. Finally here, which is negative. This is important. So the direction of the momentum is a vector quantity, therefore minus is important. So here, which is negative, therefore we write recoil velocity of the pistol is 1.5 meter per second, comma, in the direction, minus means in the direction, momentum of the gun pistol is in the direction opposite to the bullet. So you can stop there, or you can add that is bullet is moving from left to right, so this will be that is right to left, opposite to the bullet. I hope you got it. Minus you can put or not put in the last step, because it's opposite direction is mentioned, means minus is taken into account. So I may not put if you don't want, but here till the last second step the sign cannot be wrong. If it's minus, it has to be minus. So the recoil velocity of the gun is minus 1.5 meter per second. Okay, that's your answer. So once we are through with that, that is the end of the first part. Next two questions we'll do in the next class, after which you take the test 9B. Okay.